Hello, I'm Amara, Mr. Frain's AI agent, and today I'm honored to introduce an exceptional professional. Meet Bernard D. Frain, an AA-certified professional and seasoned health, safety, and environment expert with more than 16 years of experience in the construction and oil and gas industries. Bernard possesses internationally recognized safety qualifications and some of the highest global safety certifications, demonstrating his dedication to world-class standards, leadership, and professional excellence. By combining artificial intelligence knowledge with extensive HSE expertise, Bernard is leading a new direction where technology and safety work together to create smarter, safer, and more efficient workplaces. His passion is clear: to educate, inspire, and empower people through safety and AI awareness, helping shape the future of learning and workplace excellence. I'm Amara, and together, welcome to the future of safety and AI with Bernard D. Frain. Welcome to Slide 2. Today, I want to walk you through the capabilities and workflow of the AI Math Solver. By the end of this section, you'll understand how to use the tool effectively, from preparing better inputs to reading step-by-step solutions, verifying results, and applying it across different contexts like homework, training, tutoring, or even professional calculations. We'll explore each stage in plain language, so you know exactly how the AI works and how to use it responsibly. This way, you can avoid blindly copying answers and instead focus on learning and understanding the problem-solving process. Remember, the AI Math Solver isn't just about giving answers. It's a guided reasoning assistant. It interprets your problem, chooses the right method, shows the logical steps, and helps you learn along the way. What we aim for in this training is to turn confusion into clarity, so you'll confidently understand how the tool functions and how it can support your learning journey. Let's take a closer look at the AI Math Solver capabilities workflow. Starting from the top, the first step is reading the problem, where the AI can interpret typed text, scanned handwriting, screenshots, or even equations. Next, it breaks down the task into manageable parts, making complex problems easier to handle. Then, it solves the problem using rules and patterns, applying mathematical logic to find the solution. After that, it explains each step along the way, ensuring the user understands the reasoning behind every move. Finally, it checks the answer quality to confirm that the solution is correct and reliable. This entire workflow demonstrates how the AI acts as a digital tutor, integrating recognition, reasoning, calculation, and explanation to guide users from a question to a clear, checkable solution. Let's take a closer look at the capabilities workflow of the AI Math Solver. First, it checks assumptions, units, and the final answer to ensure everything makes sense and is accurate. Verification is key to building confidence in the solutions provided. Next, the solver offers support for graphs, geometry, and diagrams, which is incredibly helpful for visual learning. It shows the reasoning process behind the problem, not just the final answer, so you can understand how the solution is derived step by step. The solver reads problems in various formats: typed, printed, or handwritten, making it versatile and easy to use in different contexts. It also recognizes the type of problem you're working on, which helps it apply the right approach from the start. All of these features come together in what we call the capability map, highlighting the main areas where AI Math Solver provides support. These tools aim to make learning more interactive, accurate, and transparent, aligning with the overall goal of enhancing understanding through technology. Now, let's take a closer look at the AI Math Solver capabilities workflow. This slide highlights the step-by-step process that underpins the system's effectiveness. The key message here is that the workflow is the most important concept to grasp. Strong outputs always start with clear, precise inputs, and they conclude with verification to ensure accuracy. You can see the numbered steps, beginning with recognition, where the system captures the problem. Then it moves to classification, understanding what type of problem it is. Next is solving the problem, followed by explaining the solution in a way that's understandable. After that, verification confirms that the answer is correct, and finally, applying the knowledge consolidates learning. At the bottom, there's a simplified model: capture, understand, solve, explain, verify, apply. That encapsulates the entire process. Remember, each step builds on the previous one, emphasizing that quality inputs lead to quality outputs. This workflow isn't just a sequence. It's a framework that ensures learners can trust the system and develop a deeper understanding of math problems through clear, logical steps. It's a cornerstone concept for the whole presentation. When using the AI Math Solver, it's important to first confirm that the AI has copied the problem correctly before we move on to solving. Pay close attention to details like signs, exponents, fractions, variables, and units, because even small mistakes can lead to incorrect solutions. Next, always include all the relevant information in your problem statement. This means making sure you've listed all the given values, clearly indicated units, included any diagrams, and clearly stated what the question is asking. A well-defined problem statement helps reduce wrong assumptions and makes it easier for the AI to understand exactly what you need. For input options, you can type out an equation or a word problem, upload a photo of handwritten work, provide a screenshot from a worksheet or PDF, or even use voice-to-text for simple questions. Remember, the AI can only solve problems it can correctly read and interpret, so clarity is key. Now, when capturing the problem, focus on doing it clearly. Whether you're typing, photographing, or speaking, make sure the problem is legible and complete. This step is essential because the accuracy of the AI's solution depends on how well it understands the problem you've presented. So, at the core of the AI Math Solver capabilities, the first step is for the AI to truly understand what the problem is asking before it even starts calculating. It doesn't just jump straight into solving. It needs to grasp the mathematical intention behind the words. For example, if I say, a number increased by 7 equals 20, the AI converts that into an equation like x plus 7 equals 20. Once it understands the intention, it then proceeds to solve for x, which in this case is 13. This process involves translating the natural language into structured mathematical expressions, equations, constraints, and variables. It's about converting words into the language of math. But before that, the AI must understand what the problem is asking for. That's where language parsing comes in. It identifies symbols, handwriting, graph labels, and the overall structure of the equation. And for real-world inputs, like handwritten notes or graphical data, the AI uses visual recognition to turn that into clear, structured mathematical meaning. So this step, recognize, parse, and translate, is all about bridging the gap between natural language and formal math, enabling the AI to interpret and solve problems accurately. Now let's look at how the AI can help us choose the right solving strategy. First, it's important to understand that different types of problems require different methods. For example, when working with statistics, the AI might calculate the mean, variance, probability, or even perform regression analysis. It explains why a particular method was chosen, which helps build your confidence and reduces mechanical copying. In geometry, the AI uses formulas, theorems, diagrams, and angle relationships to guide problem solving. For calculus, it can differentiate, integrate, apply limits, or optimize functions. When tackling algebra, the AI isolates variables, simplifies expressions, or solves equations. The key point here is that selecting the appropriate strategy depends on the problem type. The AI's role is to identify what approach fits best and explain why. It's not just about getting the answer, but understanding the reasoning behind it. This step, step 3, is all about choosing the most effective solving method for each unique problem. Let's take a closer look at the AI Math Solver capabilities workflow. When the solution seems to be moving too quickly, it's important to ask questions like, why this step? Or explain like I am a beginner. This helps reinforce understanding. A key learner habit is to understand not just the final answer, but each step along the way. The AI should clearly show that each step keeps the equation balanced. It should explain the operation, the reason for doing it, and the result. For example, when subtracting 5 from both sides, the AI should show 3x equals 15. Then, dividing both sides by 3 results in x equals 5. Finally, it's good practice to check the solution. 3 times 5 plus 5 should equal 20, which confirms the answer is correct. The main idea here is that the value isn't just the final number, but the reasoning process itself. Solving step by step makes the solution transparent and helps learners understand how to approach similar problems. Remember, the goal is to guide learners through each step, emphasizing why each move is made, and fostering confidence in solving equations systematically. Verification is the professional difference between just receiving an answer and truly trusting it. It's about making sure the solution makes sense and is reliable. One of the first steps is to look for missing values, domain limits, or answers that seem impossible given the context. It's important to review the assumptions we made during the solving process to ensure they're valid. We also need to double-check that units like centimeters, meters, SAR, seconds, or percentages are correct, because mismatched units can lead to errors. Next, we verify the answer by putting it back into the original equation to see if it actually works. This substitution helps confirm that the solution is correct within the problem's framework. Additionally, visually confirming intersections, shapes, trends, or constraints can provide a deeper understanding. Graphing the result allows us to see if it aligns with what we expect visually. Using graphs, diagrams, substitutions, and logic checks together helps build confidence in our solution. So, step 5, visualizing and verifying, is all about combining these approaches to ensure our answer isn't just mathematically correct, but also meaningful and trustworthy in real-world terms. Now, let's take a closer look at the AI Math Solver capabilities workflow. One key point to keep in mind is that for advanced or high-stakes mathematics, it's important to treat the AI output as a learning aid rather than a definitive solution. Always verify the results independently to ensure accuracy. The workflow starts with translating real-life situations into equations and constraints, which is fundamental for solving practical problems. The AI can handle word problems, breaking them down into mathematical expressions. It also supports areas like probability, averages, distributions, and data interpretation, crucial for understanding real-world data. Moving into statistics, the AI can assist with concepts like limits, derivatives, integrals, and basic optimization, core ideas in calculus. When it comes to calculus itself, it helps with calculating areas, volumes, angles, and applying the Pythagorean theorem in geometry. In geometry, the AI can assist with more visual or spatial problems such as understanding areas, volumes, and angles. For algebra, it supports solving linear equations, systems, inequalities, and functions, which are foundational skills. Basic arithmetic, including fractions, decimals, percentages, and ratios, forms the building blocks of more complex math, and the AI can support learners at this level too. Finally, understanding where the AI Math Solver can be most useful for learners and trainers is essential. It's a versatile tool that supports a wide range of problem types, helping users grasp concepts more effectively and work through various math challenges with confidence. Now, let's take a closer look at the AI Math Solver capabilities workflow, specifically the ethics check that we should always keep in mind. First, I ask myself, did I follow my school or workplace policy? It's essential to ensure that we're adhering to the rules regarding the use of AI tools. Next, I consider, can I explain the answer in my own words? This helps verify that I truly understand the solution, rather than just copying it. Then, I reflect on, did I understand the method? Knowing the process behind the answer is key to learning effectively. This entire process is summarized as the 3-question ethics check. It's important to remember that submitting copied answers as your own work, hiding mistakes, avoiding practice, or skipping teacher instructions is not acceptable. On the other hand, AI can be a helpful learning tool when used responsibly. You should use AI to understand the steps, review concepts, check your practice answers, generate similar examples, or ask for easier explanations. The goal is to leverage AI to learn the method, not to bypass the learning process. Responsibly using AI in this way maintains academic integrity and promotes genuine understanding. Now that we've gone through the AI math solver workflow, let's talk about the importance of reflection. After the AI provides a solution, ask yourself what the AI did well and what might need checking. This step encourages critical thinking and helps identify any potential errors or misunderstandings. Next, consider substituting, graphing, or comparing the AI's answer with manual calculations. These strategies help verify accuracy and deepen understanding. Moving on to the verification step, break down each AI step into human language. This makes it easier to see exactly how the AI arrived at its solution and whether the reasoning makes sense. Then, take a pause and explain the solution, capturing the problem and requesting beginner steps if needed. This ensures clarity and supports learners who might be new to the process. Before the AI runs its solution, ask learners to predict the method. This primes their thinking and engages them actively in the problem-solving process. At the start, always show the problem, be it a sample equation or a word problem, so students understand what we're working on. Finally, remember that this workflow provides a clear sequence for confident classroom delivery, helping trainers guide students through the AI solution process smoothly and effectively. On this slide, we're looking at the AI math solver capabilities workflow. First, there's the prompt principle. You tell the AI the problem, specify your level, choose the explanation style you want, and indicate how you want the answer checked. For example, you might ask it to create 5 similar questions with answers after you try them. This is great for practice. Next is the practice generator, which can show you 2 different methods to solve a problem and then tell you which one is easier for a beginner. This helps you understand different approaches. Then we have method comparison, where the AI reviews your solution, spots any mistakes, and explains how you can correct them. There's also the Check My Work feature, where the AI solves a problem step by step and explains each part in simple words, helping you learn each step thoroughly. Finally, the beginner explanation is about teaching learners how to ask clear and professional questions, making your communication with the AI more effective. These prompt templates are designed to help you get better, more tailored outputs from the AI, making your learning process smoother and more interactive. Now let's talk about how the AI math solver can truly deliver the best value. When used as a coach, it doesn't just give answers. It guides your thinking, explains where mistakes happen, and encourages you to practice and improve. It's like having a personal tutor by your side. This approach is especially useful for quick checks, whether it's verifying formulas, making estimates, or interpreting data. It helps users become more confident and independent in their problem solving. For professionals, the AI provides simple explanations while guiding learners through complex concepts, making it easier to understand and apply new knowledge. Parents and mentors benefit from demo preparation, practice questions, and tailored explanations that meet the specific needs of their learners. Teachers and trainers can leverage the AI for homework support, reviewing exam questions, and reinforcing key concepts, making classroom time more effective. And for students, this is where the AI adds the most real training value, helping them understand, practice, and master math skills more efficiently. Overall, these practical use cases highlight how AI Math Solver becomes a versatile tool, supporting different users at every stage of learning and teaching. Let's take a moment to understand the core of the AI Math Solver capabilities workflow. The key idea here is to learn the method, verify the answer, and build confidence. Remember, AI Math Solver is most effective when learners focus on understanding the process, not just getting to the answer quickly. The goal isn't to copy things faster, but to develop clearer thinking, greater confidence, and the ability to verify solutions confidently. As we wrap up, it's important to emphasize practice and reflection. Encourage learners to regularly practice problems and reflect on their understanding. Additionally, we should document any questions learners have along the way so they can be addressed and clarified. Teaching verification is crucial. Students should learn to check their work rather than blindly trusting the answers provided by the AI. When using AI tools, opt for beginner-friendly prompts and prepare clean, straightforward sample problems to ensure clarity. Also, select an AI math tool that suits the learner's level and needs. Finally, it's helpful to follow a simple readiness guide before starting to use the AI math solver in training. This checklist ensures learners are prepared and confident in their approach, making the overall process more effective and engaging.